By now, you've seen a lot of different learning algorithms, and if you've been following along these videos, you should consider yourself an expert on many state-of-the-art machine learning techniques. But even among people that know a certain learning algorithm, there's often a huge difference between someone that really knows how to powerfully and effectively apply that algorithm versus someone that's less familiar with some of the material that I'm about to teach and who doesn't really understand how to apply these algorithms and can end up wasting a lot of their time trying things out that don't really make sense. What I'd like to do is make sure that if you're developing a machine learning system, that you know how to choose what are the most promising avenues to spend your time pursuing. And in this and the next few videos, I'm going to give a number of practical suggestions, advice, guidelines on how to do that. And concretely, what I'm going to focus on is the problem of, suppose you're developing a machine learning system or trying to improve the performance of a machine learning system, how do you go about deciding what are the promising avenues to try next? To explain this, let's continue using our example of learning to predict housing prices. And let's say you've implemented regularized linear regression, thus minimizing that cost function j. But suppose that after you take your learned parameters, if you test your hypothesis on a new set of houses, suppose you find that it's making huge errors in its prediction of the housing prices. The question is, what should you then try next in order to improve the learning algorithm? There are many things that one can think of that could improve the performance of your learning algorithm. One thing that you could try is to get more training examples, and concretely you can imagine maybe setting up phone surveys, going door to door to try to get more data on how much different houses sold for. And the sad thing is, I've seen a lot of people spend a lot of time collecting more training examples, thinking, oh, if we have twice as much or 10 times as much training data, that's certainly got to help, right? But sometimes getting more training data doesn't actually help, and in the next few videos we'll see why, and we'll see how you can avoid spending a lot of time collecting more training data in settings where it's just not going to help. Other things you might try are to, well, maybe try a smaller set of features. So if you have some set of features, x1, x2, x3, and so on, maybe a large number of features, maybe you want to spend time carefully selecting some small subset of them to prevent overfitting. Or maybe you need to get additional features. Maybe the current set of features aren't informative enough, and we want to collect more data in the sense of getting more features. And once again, this is a sort of project that can scale up to be huge projects. You can imagine, again, phone surveys to find out more about houses, or extra land surveys to find out more about the pieces of land, and so on. So a huge project. And once again, it would be nice to know in advance if this is going to help before we spend a lot of time doing something like this. We can also try adding polynomial features, things like x1 squared, x2 squared, and product features x1, x2. You can spend quite a lot of time thinking about that. And we can also try other things like decreasing lambda, the regularization parameter, or increasing lambda. Given a menu of options like these, some of which can easily scale up to like maybe 6-month or longer projects, unfortunately, the most common method that people use to pick one of these is to go by gut feeling, in which what many people will do is sort of randomly pick one of these options. Like maybe say, oh, let's go and get more training data, and easily spend 6 months collecting more training data. Or maybe someone else will randomly say, well, let's go collect a lot more features on these houses in our data set. And I have a lot of times, sadly, seen people spend literally 6 months doing one of these avenues that they had picked sort of at random, only to discover 6 months later that that really wasn't a promising avenue to pursue. Fortunately, there's a pretty simple technique that can let you fairly quickly rule out half of the things on this list as being potentially promising things to pursue. And there's a fairly simple technique that if you run, can easily rule out many of these options and potentially save you a lot of time pursuing something that's just not going to work. In the next 2 videos after this, I'm going to first talk about how to evaluate learning algorithms, and in the next few videos after that, I'm going to talk about these techniques, which are called machine learning diagnostics. And what a diagnostic is a test they can run to get insight into what is and what isn't working with an algorithm, and which will often give you insight as to what are promising things to try to improve a learning algorithm's performance. We'll talk about specific diagnostics later in this video sequence, but I should mention in advance that diagnostics can take time to implement. It can sometimes take quite a lot of time to implement and understand, but doing so can be a very good use of your time when you're developing learning algorithms, because they can often save you from spending many months pursuing an avenue that you could have found out much earlier just was not going to be fruitful. So in the next few videos, I'm going to first talk about how to evaluate your learning algorithms, and after that I'm going to talk about some of these diagnostics which will hopefully let you much more effectively select what are useful things to try next in order if your goal is to improve the performance of your machine learning system.